So now that we've done asymptotes and domain, we can now look at graphing rational functions. So here are some steps. First, we're going to find any real zeros of the denominator. This helps us find the domain and identify vertical asymptotes. The second step is to find the horizontal or oblique asymptote. Third step is to find any zeros, which are the zeros of the numerator. And these will give us the x-coordinates of the graph. And then the next step is to find f is 0. That will be the y-intercept. And then the last step is to find other values, but you can also use a graphing calculator to really, and the table function to find other values. So in example 6, we're going to graph the rational function f of x equals 2x plus 3 over 3x squared plus 7x minus 6. To find the real zeros of the denominator, we're going to factor this out. We know the factors of 3 are 1 and 3. So I can use that. So we have x, and then we have 3x. And then we need the factors of 6, which are 1 and 6 or 2 and 3. You can guess and check if you'd like. And so we need the 7. And so the best place to put these factors are x plus 3 and 3x minus 2. Okay, so this is going to be the one that works. So I have it in factored form now. Set each of the factors equal to 0 in the denominator, solve for x, and we get x equals 3, or x equals -3 and x equals 2/3. So our domain is x can't be -3 or 2/3. The vertical asymptotes are the restrictions on the domain. So x equals 2/3 and x equals -3. I have a picture of my graph over here. I'm going to go ahead and draw those vertical lines. All right, so we have our two vertical asymptotes. And notice we have three regions for which the graph is going to be shown. Let's see, we have a horizontal asymptote. When we look at the degree of the numerator is 1. The degree of the denominator is 2. Since 1 is smaller than 2, we know that the horizontal asymptote is y equals 0. So we can draw that line here. So now we're going to find the zeros of the function to see where it crosses the x-axis. We get the numerator, set equal to 0. So 2x plus 3 equals 0. Solve for x, and we get -3/2. So I'm going to go ahead and plot that point on my graph. Let's see, that's -1, that's -2, so it's at in between that. That's right here. So that's at x equals -3/2. So that tells me that my function will be crossing that 0 inside these two vertical asymptotes. It'll be cubic-like in nature there. So to find other points on my graph, you might try, let's see. Oh, before I get the other points, we're going to find the y-intercept. So that is, where does it cross the y-axis? And that's at f of 0. When I plug that in, I get -1/2. So 0, -1/2 is right here. Now that gives me a lot of information about what's going on in the middle. Because it's decreasing on the right, it's going to hug the vertical asymptote, and then it will rise to meet the leftmost horizontal, vertical asymptote. Okay, and then to find the others, we can just simply, for step 5, find other points like f of -4 and f of positive, let's see, on the other side of 2/3 might be 1, okay? So if you can find those, plug it into your equation, or just use the table and you can graph it. So now that you have a graphing, with your graphing calculator, you can now use algebra and use these steps to find the exact vertical and horizontal asymptotes. Now, in the next example, we have a hole in the graph for this one. So we're going to go ahead and factor this out, but notice that x minus 2 are common factors. All that tells me is that x equals, can't be 2 or -1. All right, so that's my domain. Okay, but the 2 tells me, because it's a common factor, that we have a hole in the graph at x equals 2. So we plug that into the function and find f of 2, and we get 1/3. So I'm going to go ahead and use my graph and plot that point. So at 2, we have 1/3. So we have a hole in the graph right here. Your TI-84 is going to look pretty continuous on either side of it. So this could be kind of a hidden hole in there. The only way to determine that there's a break in the graph is really by going to the table. And if your x, when your x is 0 and you get an error in your y, then we know that there is either an asymptote or a hole there. The second step is find the real zeros of the denominator in its factored form, so we can find the vertical asymptote. So x plus 1 equals 0, therefore x equals -1 is a vertical asymptote. The horizontal asymptote is, well, we have to compare the numerator degree and the denominator degree. Since 0 is smaller than 1, then y equals 0 is the y asymptote. Okay. And then to find the y-intercept, we look for f of 0, and we calculated that as 1. So 0, 1 is on the graph right here. And so that tells me that the graph in the upper right quadrant is known because of that 1 point. We do have a hole there. Okay. To sketch the other side of the vertical asymptote, we only need to maybe find one of our points. So we'll try f of maybe -2, and that's equal to 1 over -2 plus 1, which is -1. So we're down here, and that tells me we're going to graph below the horizontal asymptote.